So for question 3, we're finding the area of a parallelogram by using the triangles. So in a parallelogram ABCD, the distance of AB is equal to 7 units, the distance of CB is equal to 4 units, and angle A is equal to 117 degrees. What is the area of ABCD? So I'll just go through the steps. So the formula for the area of a parallelogram uses the length of the base and the height. However, if you know only the measures of 2 consecutive sides and 1 angle, you can't easily use this formula. You can use the properties of triangles and parallelograms to find the area of half the parallelogram. So what they're saying is we could use the triangle right here since we know the formula with the area of a triangle, including the sine of that angle. We can use if we have the 2 sandwiched sides that sandwich out that angle. So they want to know what is the length of a segment AD right here, because that's the other sandwiched side of this angle, 117 degrees. So one thing we do know about parallelograms is that opposite side lengths have the same measure. So this side length would be 4. Likewise, the opposite side length of BA is CD, and it would be 7. So that's just some information to know. So we would say that the length of segment AD is 4 units because the opposite sides of parallelograms are congruent. That is correct. And what is the area of triangle ABD? Right here, rounded to the nearest hundredth. And I kind of fundamentally disagree with this step, because if you understand what this formula is meaning, you would understand that the reason for this 1/2 is because it's taking into account that it's only talking about half of a parallelogram or a rectangle or a square. So right here we could automatically, if we are looking, if our goal is to find the area of a parallelogram and we fundamentally knew that the 1/2 came because I was looking at half of the area of that, which is the triangle, then we could write the formula as the area is equal to, not the 1/2, because I want the whole area of this figure because it's the parallelogram, not the triangle that we're going for, would be 7 times 4 times the sine of 117 degrees. So that is the step that I would have taken right now, because there's a connection between that 1/2 and the segment of the triangle that is in the parallelogram. This step though is wanting us to find the area of this triangle, so I will add in that 1/2 and we'll go that route. So we have 7 times 4, we have 1/2 times 7 times 4 times sine of 117 degrees. 12.47, and since this is a 4, that 7 will not be rounded up. 12.47 units for that triangle. So again, what is the area of parallelogram ABCD? So this is why I was saying this step is kind of not necessary, because if you understand where that 1/2 comes from, it's understanding that the triangle is half of the parallelogram and we want the whole parallelogram. So to find out the whole parallelogram, we would multiply it by 2. So multiply that by 2, and that's 24.94. So again, I'll just show you this if we had 7 times 4 times the sine of 117 degrees, it's 24.94. So again, this middle step, if you're looking for the area of a whole parallelogram or whole rectangle or whole square, multiplying it by that 1/2 is an unnecessary step because you end up undoing it by multiplying it by 2, because 2 times all of this, if you were to just look at it, well, 2 times 1/2 is just 1. So we have 1 times 7 times 4 times sine of 17. So that's what I mean by undoing it, is it reduces down to 1. It doesn't have an impact on it. So I hope that helps.